Welcome to the Yellow Belt section of the ECG Mastery program. We're really happy to have you in our course. We created this belt system for you for two reasons. One is we really like martial arts, and the other one is it's easy to understand. Most people know that the yellow belt is the first belt that you can acquire in most martial arts like karate or judo. The owner of the yellow belt knows the basic principles of the sport, the names of the moves, and so forth. Similarly, once you finish the yellow belt section in this course, you'll know the basic principles of the ECG, you'll be able to diagnose very important and potentially dangerous diseases, and you'll understand your colleagues and reports that talk about an actual ECG. And that enables you to further improve your ECG skills on the job. It's very hard to learn from someone if you don't speak their language, right? So in this yellow belt section, we'll teach you the ECG language so you'll be fluent real quick. But let's not waste any time and dive right into the heart of the matter. May I introduce to you the ECG curve. It consists of several distinct waves. Let's look at these waves in more detail.
Let me give you a short intro into the components of the ECG. Let's start off with the QRS complex. The QRS complex represents ventricular depolarization. These QRS complexes are easy to recognize. They're very sharp and pointy spikes. After each ventricular depolarization, there must also be a period of repolarization, and that repolarization is called T wave. The T wave can be positive or negative. Depolarization of the atria, on the other hand, is characterized by a relatively steep wave, called the P wave. Its steepness is somewhere between that of the QRS complex and the T wave. So this is the QRS complex, and it's the steepest part of the ECG. This is the T wave, and it's the least steep part, and the P wave is somewhere in between. We usually can't see atrial repolarization, mainly because it's usually hidden within the QRS complex.
Let's have a closer look at the QRS complex, which, as you know, corresponds to ventricular depolarization.
Each component of the QRS complex has its name. Naming of these components follows a standard nomenclature. There are only 5 basic concepts that you have to understand when it comes to naming these components.
Concept number 1, the first downward deflection is called a Q wave. Concept number 2, any upward deflection is called an R wave. Concept number 3, any downward deflection that comes after an R wave is called S wave. Concept number 4, a second upward deflection is called R prime. And what about this wave here? Is this a Q? Is this an S? Well, to tell you the truth, people came up with a compromise here. They said that whenever there is one large downward deflection, then that's called a QS pattern. So concept number 5 says, if the entire QRS complex consists of one large downward deflection, then this is called a QS wave.
That's it. Now let's look at a couple of examples.
Example number 1. Here we have a rather classical case. According to concept number 1, the first downward deflection is called a Q wave. According to concept number 2, any upward deflection is called an R wave. And concept number 3 says any downward deflection that comes after an R wave is called S wave. So we have a QRS pattern here. Now let's check out example number 2. As you can see, we have no initial downward deflection in this case. So according to concept number 2, any upward deflection is called an R wave. So no Q wave here. And according to concept number 3, any downward deflection that comes after an R wave is called an S wave. So we have an RS pattern here. Now let's turn to example number 3. What I'd like you to do here is pause the video and try it out for yourself. Then come back and see how you did. Okay, so now let's see how you did. According to concept number 2, any upward deflection is called an R wave. According to concept number 3, Any downward deflection that comes after an R wave is called S wave. And according to concept number 4, a second upward deflection is called R prime. So we have an RSR pattern or RSR prime pattern here. Did you get it right? Okay, so let's try another one. Again, pause the video and try for yourself. Then come back and see how you performed. Okay, so let's see the solution. According to concept number 1, the first downward deflection is called a Q wave. According to concept number 2, any upward deflection is called an R wave. So we have a QR pattern here. Are you ready for some more examples? Well, here we go. Example number 5. Again, pause the video and try for yourself. That was simple, wasn't it? There's only one concept that you have to use here, and that's concept number 2. Any upward deflection is called an R wave. But let me tell you one thing. This type of R wave is actually quite rare. Usually we would see a Q wave here or an S wave here, so you will only rarely see this type of R pattern. And one final example, example number 6. Pause the video and try for yourself. Also quite easy. Only one concept fits here, and that's concept number 5. If the entire QRS complex consists of one large downward deflection, then this is called a QS pattern.
Here are the different examples again. Take a close look at them. Example number 1, we had a Q wave, an R wave, an S wave. Example number 2, an R wave and an S wave. Example number 3, R, S, R prime. Example number 4, a Q wave and an R wave. In example number 5, just one big upward deflection. That has to be an R wave. And in example number 6, just one big downward deflection, which of course has to be a QS pattern.
It's time for another little exercise. Now it's your turn to identify the different components of the ECG. Try to identify the QRS complexes and the T waves first and then the P waves. So pause the video and try for yourself, then come back and see how you did. Okay, so I hope you did the exercise. Let's see how you did. This first part of the curve, very steep and pointy, must be a QRS complex. Then after each QRS complex, there has to be a T wave, so this has to be the T wave. Then this is another steep part, QRS complex. This must be a T wave, rather flat. QRS complex, T wave, QRS complex, T wave, QRS complex, and another T wave. So what we're left with are a couple of unidentified dotted lines and ECG curves. And those curves must be the P waves because the QRS complexes and the T waves we've already identified. So this must be a P wave. This must be a P wave. Another unidentified line must be a P wave. And then another P wave here and another P wave here. What's striking here though is that the P to P interval here seems fairly long, and those 3 P to P intervals seem much shorter, right? So these 3 seem to be constant, and then there seems to be a big pause. And one important thing to note is that the P's are only very, very rarely skipped. So we assume that the P wave must be hidden somewhere in this interval. But where? Well, the way to solve this mystery is to take the P to P interval, the regular P to P interval, which would be this. These are 3 regular P to P intervals. And then take this P to P interval and put it right here at the first part of this pause. So we put it here, and so we see that this is the area where we would expect the P, right? So this is where the P is supposed to be. And I can tell you the P is actually hidden within the QRS complex. That's why those 2 are happening at the same time. And then comes another regular P to P interval. So the mystery for this long pause is solved. But then we have another little mystery. Here, in the period that comes before this P wave, there's no P happening here. So let's take the P to P interval, and we can see that this is the area where we would expect the missing P. And if you look closely down here, you can see that we have a little bit of notching here. That's probably because the P wave is hidden within it.
Now try for yourself. Start the exercises and see how you're doing, and I'll see you in the next session.